This is lesson 4.7, arithmetic sequences. Your objective is to identify and extend patterns in sequences. It is also to represent arithmetic sequences using function notation. Some vocabulary. Sequence. A sequence is an ordered list of numbers that often forms a pattern. Term of a sequence. A term of a sequence is any number in a sequence. An arithmetic sequence is a number sequence formed by adding a fixed number to each previous term to find the next term. The common difference is the difference between consecutive terms of an arithmetic sequence. A recursive formula defines the terms in a sequence by relating each term to the ones before it. And an explicit formula expresses the nth term of a sequence in terms of n. When you can identify a pattern in a sequence, you can use it to extend the sequence. You can also model some sequences with a function rule that you can use to find any term of the sequence. For example, describe a pattern in the sequence. What are the next two terms of the sequence? Here is our sequence, and we need to figure out the pattern. So it looks like, well, to get from 5 to 8, I add 3. 8 to 11, I can add 3. So wait, the pattern is add 3 to the previous term. So to find the next two terms after 14, we just add 3 to 14 and get 17. And then to get the next term, I use the previous term, 17, add 3 to that to get 20. In an arithmetic sequence, the difference between the consecutive terms is constant. This is called the common difference. Tell whether the sequence is arithmetic. If it is, what is the common difference? 3, 8, 13, 18 is an arithmetic sequence. And I know this because to get from 3 to 8, I have to add 5. 8 to 13, I have to add 5. So the difference between the terms is 5. 6, 9, 13, and 17 is not an arithmetic sequence. And there is no common difference because to get from 6 to 9, I add 3, but 9 to 13, I have to add 4. And then 13 to 17, I add 4 again. But this is not consistent, so it is not an arithmetic sequence. A sequence is a function whose domain is the natural numbers, and the outputs are the terms of the sequence. You can write a sequence using a recursive formula. A recursive formula is a function rule that relates each term of a sequence after the first to the ones before it. For example, we have 7, 11, 15, and 19. So again, the first term is 7, the second term is 11, the third term is 15. So the domain of the sequence are the natural numbers referring to the terms. So first term, second term, third, fourth, fifth, the natural numbers. The outputs are the terms, the actual value of the term. So the first term value is 7, second term value is 11, 15, 19, and so on. You can use the common difference of the terms of an arithmetic sequence to write a recursive formula for the sequence. In this example, the common difference is 4. So first we need to define that the variable n will represent the term number in the sequence. Again, that refers to first term, second term, third term, fourth term, and so on. The function a of n is the value of the nth term of the sequence. So it's the value of the term. So for example, we have term 1. When n equals 1, the value of term 1, a of 1, is equal to 7. The value of term 2, meaning the second term, has a value a of 2 equal to the value of the first term plus 4, which equals 11. Well, I get that because I know the value of the first term is 7, so I substitute that into my equation. The value of term 3 is equal to a of 3 equal to the value of term 2, a of 2, plus 4, and we know that a of 2 was equal to 11, so I just plug that in and I get 15. The value of term 4, a of 4, is equal to the value of the third term, which was 15, plus 4. So I just continue adding to the previous term, but I use the function notation to represent each of the values. So now I can find the nth term, the value of the nth term, a of n, by taking the value of the previous term, so I do n minus 1, since that will give me the term before it, plus 4. So the recursive formula for this arithmetic sequence is a of n, the value of the nth term, is equal to a of n minus 1, the value of the previous term, plus 4, where a1 equals 7. You must indicate where what the first term of the sequence was when you write your recursive formula. Do not just write the recursive formula without this part. This is essential because just looking at this, well, if I look at a of n equals a of n minus 1 plus 4, how do I know what my first term value is? If I plug in 1 for n, well, 1 minus 1 is 0. I don't have a value for a of 0 because I don't have a 0 term. So you must indicate where your sequence begins. This is very important. Write a recursive formula for the arithmetic sequence 70, 77, 84, 91. The common difference is adding 7, so that is our common difference, that's the pattern. Now we can write our recursive formula. So the nth term, whatever term we're looking for, if we're looking for the 5th term or the 6th term, a of n is equal to a of n minus 1, so the term right before it, that value, plus 7, where a of 1, meaning the value of the first term, is equal to 70. This is the recursive formula for this sequence. You can find the value of any term of an arithmetic sequence using a recursive formula. So once I find the 4th term, I can find the 5th term, then the 6th, then the 7th. However, this can become very time consuming, so that now we go into explicit formulas. So you can also write a sequence using an explicit formula. An explicit formula is a function rule that relates each term of a sequence to the term number. So the arithmetic sequence was a function rule that related to the previous term, but this explicit formula relates to the term number. So what does this mean? The nth term of an arithmetic sequence with the first term a1 and common difference d, so meaning we know what the first term value is and we know what the common difference is, and we can find the nth term by writing this. A of n is equal to the value of the first term plus the common difference multiplied by how many terms were before it, so n minus 1. Meaning, so a of n is referring to the nth term, a of 1 is referring to the value of the first term. Since n is referring to that term number, so let's say we're looking for the 7th term, then n minus 1 would be 6 times whatever the common difference is. And then we would just add that to the first term. Now we can find the nth term, like the 7th term, without having to figure out the 2nd, 3rd, and 4th, and 5th, and 6th term. We could just figure it out from the explicit formula. An arithmetic sequence is represented by the recursive formula a of n equals a of n minus 1 plus 12. If the first term of the sequence is 19, write the explicit formula. So first you need to state that the first term, a of 1, is 19. You need to identify that. Well, a of n is equal to a of n minus 1 plus 12. This is the recursive formula. Adding 12 to the previous term means that the common difference is 12. So this 12 is our variable d. So our explicit formula, remember, is the nth term value equal to the first term value plus n minus 1, so all the numbers of the terms before it, multiplied by d. A of n is equal to, well, we know the first term value is 19, a of 1, so I can replace that a of 1 with 19 plus n minus 1, and I know that the common difference is 12, so I can substitute that in for d. So the explicit formula is a of n equals 19 plus n minus 1 times 12, represents the arithmetic sequence. Notice here I do not need to write what a of 1 equals because it's already built in to my formula. Writing a recursive formula from an explicit formula, an arithmetic sequence is represented by the explicit formula a of n equals 32 plus n minus 1 times 22. What is the recursive formula? First we need to identify parts of this explicit formula. So 32, remember, comes from our first term. 22 is our common difference. So that means a recursive formula relates the value of the term to the previous term using the common difference. I'm going to use a of n to represent the value of the term that I'm looking for, and a of n minus 1 to represent the previous term's value. So the arithmetic sequence is represented by the recursive formula a of n equals the previous term a of n minus 1 plus 22, and now we have to include this because it's a recursive, where a of 1, the value of the first term, equals 32. Tell whether the sequence is arithmetic. If it is, what is the common difference? 8, 15, 22, and 30. Well, I have to add 7 to get to 15. If I add 7 to 15, I get 22. If I add 7 to 22, I should get 29, but I have 30, so this is not an arithmetic sequence. Write an explicit formula for the recursive formula a of n equals a of n minus 1 plus 2, where a of 1 equals 21. So remember, our explicit formula looks like a of n, the value of the nth term, equals a of 1, the value of the first term, plus n minus 1 times whatever the common difference is. Well, that means I can substitute a of 1 because I know that in my recursive formula a of 1 equals 21, so I can replace that here, plus n minus 1, and I know that my common difference is 2 because that was also given in my recursive formula here. So my explicit formula for the recursive formula is a of n equals 21 plus n minus 1 times 2. Write a recursive formula for the explicit formula. So remember, our recursive formula depends on the previous term, and we're not just looking for the nth term value. So it has to be related to the previous term plus the common difference. Well, I know the common difference is 10 because that is in my explicit formula here. But I can't just write my recursive formula like this. I must make sure that I add where a of 1 equals 76. Because if I do not mention that, then I don't know where my sequence starts. And that is given right here in the explicit formula. So my recursive formula for the explicit formula is a of n equals a of n minus 1 plus the common difference 10, where the first value, a of 1, is equal to 76.